Welcome to Math Tape 055, Evaluating Powers and Rational Expressions. As you watch the tape, take very careful notes, and on your notes, mark any places that you don't understand or any places where you make a mistake in an exercise that I shall give you. Then ask a lab instructor or a tutor for help when you go to the lab. As we work through this tape, recognize that we're going to be using all of the rules that we have learned about adding, subtracting, multiplying, and dividing rational numbers. We also will work with powers, exponents, and we'll put all of this together. This tape is the heart of the unit about rational expressions, so plan to do a really good job on this one. On this tape we have two objectives: evaluate powers having rational bases and natural number exponents, and evaluate rational expressions. Evaluate powers having rational bases and natural number exponents, and evaluate rational expressions. We'll begin with powers, and you need to begin by recalling what a power means and how we write such a thing. Repeated multiplication of the same factor can be written using a base and an exponent. Repeated multiplication, we're multiplying something repeatedly over and over again. Repeated multiplication of the same factor can be written using a base and an exponent. For example, 3 times 3 times 3 times 3 uses the same factor, 3, repeatedly. Factors of things that are multiplied, we have repeated multiplication. The base is 3, the exponent is 4. This is read 3 to the 4th power. Base 3, exponent 4 is read 3 to the 4th power. The base in the exponential expression can be any rational number. The base may be any rational number. For example, we could have -2 with the exponent 2. That means -2 used as a factor 2 times, -2 times -2, and of course the answer is 4. We can have a fraction, -3/4 to the power 3. This means -3/4 is used as a factor 3 times. -3/4 times -3/4 times -3/4. Multiplying, we multiply -3 times -3 to get +9. +9 times -3 gives -27. For the denominator, 4 times 4 is 16. 16 times 4 is 64. Our answer is -27 over 64. Remember that we must always leave a fraction in reduced form. Can you reduce this one? Well, think about it. If you can reduce this answer, that means we could have done some reducing in the problem. That is, we could have canceled. But notice that numerators of -3, denominators of 4 have no common factors. That means we cannot reduce before we multiply. Therefore, we cannot reduce after we multiply. So -27/64 is the correct answer. A very important note, an exponent applies to the last expression before it unless parentheses include more. We must know what the base for an exponent is in order to evaluate it. This rule tells you the exponent applies to the last expression before it unless parentheses include more. Be sure to write this rule down, this note down, very carefully. Make sure you have it exactly right. An exponent applies to the last expression before it, unless parentheses include more. For example, if we multiply negative 3 times 4 squared, notice the exponent 2 applies to the 4. It does not apply to anything preceding the 4. The exponent applies only to the 4. That means that the negative 3 is kept as a factor, and then 4 squared means 4 times 4, which is, of course, 16, and 3 times 16 is negative 48. So negative 3 times 4 squared works out to be negative 48. Another example, and this one a lot of people find confusing, so pay really close attention here. This says a minus sign, then a 5, then an exponent 2. How much does this exponent apply to? Well, notice that our note says an exponent applies to the last expression before it, unless parentheses include more. The expression before this exponent is the number 5. Not negative 5, but simply 5. That means that we read this minus sign as the opposite of. Therefore, the opposite of 5 squared means the opposite of 5 times 5, which is the opposite of 25, and the opposite of 25 is negative 25. That is, the opposite of 5 squared is negative 25. If we want the exponent to apply to the minus sign as well as the 5, we must use parentheses. An exponent applies to the last expression before it unless parentheses include more. In this example, the parentheses do include the minus sign. Therefore, the exponent does apply to the minus sign as well as to the 5. So, negative 5 squared is negative 5 times negative 5, which is positive 25. Notice very, very carefully the difference between these two examples. Many people have trouble with this. Don't let yourself be among them. This says take the opposite of 5 squared. The example below it says take the square of negative 5. Let me give you some exercises now to try. Copy these down, stop the tape, work the problems, turn the tape back on and check your answers. The exercises say to evaluate. Exercise 1 is negative 6 in parentheses with an exponent 2. Exercise 2 is the opposite of 6 squared. Exercise 3, negative 5/8 times, in parentheses, 1/3 with an exponent 2 outside the parentheses. Exercise 4, the opposite of 2 to the 4th power times 3 to the 2nd power. Exercise 5, in parentheses, negative 1/10, outside the parentheses, exponent 2, in parentheses, negative 5. The answers you should have are, your answers should be, for number 1, 36, for number 2, negative 36, for number 3, negative 5 over 72, for number 4, negative 144, and for number 5, negative 5/100ths.